Okay, so when you guys go to grades, so everyone at this point, I think, has registered for Connect, but that's 0 points, so nobody really cares about it, but it's important because it determines on whether you're going to get your Connect points or not, right? Everyone's done their introduction, I think, and it should have been graded on that. So that'll be part of your midterm grade. We have taken test 1, so that will be part of your midterm grade. If you have not done the agreement, do it, because that is part of your midterm grade, and I'm going to grade it again tomorrow because they've extended midterm grading, so I'm probably not going to actually enter them officially into Lola until tomorrow. So if you're one of those few people that haven't done it, do it, because I'm not going to grade it again, right, because it's past the deadline. Like 2 weeks past the deadline now. Yesterday was the deadline for chemicals to use, and I think most of you guys have done it. But if you're one of the few that hasn't done it, get it done this week. It's not going to be part of midterm grade because I don't have time to grade that huge of an assignment before getting those grades in. But I will be grading them sometime very soon. So if you're one of the few that didn't make this deadline, get it done before I grade, because once I grade, I'm not going back and regrading. Is that clear? Okay.
On almost like everything I had, I finally found one that didn't, but it just says ingredients. Does that mean they're active or inactive?
That's a good question.
Like, my mom was like, pick something else. I picked something else. Same thing. I was like, what the heck?
Right. So write that. You know.
Well, I picked something that I found something.
Oh, okay.
I was like, I'm not getting this wrong.
But you know, part of the reason why so she was asking, you know, it just says ingredients. Does that mean they're active? Probably not, for one. But two, that's partly why we're doing this activity is to inform you guys of what's in the things that you're using, right? And what are they actually doing, right? And does everything you clean with have to disinfect? No. 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 Right? We don't need antibacterial soap, y'all. They've just duped us into thinking we believe it and of using it as a marketing scheme. I kid you not. Right? They've used our fear of microbes to ruin the environment. Right? My son told me yesterday, I love this, right? We're driving to soccer practice. Like, we have like 15 minutes to get there, right? He's like, we shouldn't drive, Mom. We're polluting the air. I'm like, oh, I love your teachers right now. Let me explain to you, child, why we're driving. One, we would never get there on time if we had to walk or take public transportation to get there. I said, but, you know, Mommy is going to get her bike fixed, and we are going to bike more often. And this is also when I can, we walk to your school. I said, I do try to reduce my carbon footprint. Right? I love little kids. You know, they just like, we shouldn't drive. Yeah, trust me, I don't like driving. But, you know, sometimes to get there on time, you got to hop in the car and drive down the road. Chemicals used to clean. So finish it up. Test 2, if you hadn't found out already, obviously I moved it back. I changed it in Canvas and posted an announcement for you guys. And, of course, all that was made possible by the fact that that time was available next week in the computer lab. So you guys, lucky stars, everything aligned for you. I got a couple thank you emails, right? The only caveat with that, y'all, is just realize that what we have left, we've got to get done still in a set time frame. So I may be a little speedy when it comes to some other stuff later on. So obviously 3 and 4 aren't in midterm grade either, or the final. One of the things that I want to tell you guys about is a bonus opportunity that's happening today from 9 to 1. And I've made it an assignment in Canvas so that you can submit that you've helped out with this activity and get bonus points. And so I'll go over that in a moment. And then for Connect assignments, Module 1, we've already completed, right? Module 2, we're still kind of in it, so I'm not going to include that in midterm grade, but I'm going to talk about that right now. So for my online students, which don't have the privilege of seeing me and seeing my reaction, and apparently signed up for online classes and yet they don't read, right? So, they don't read what I write. Sometimes people don't even listen to what I have to say, but please listen to me, right? I care about you guys. I put a lot of time and effort into setting up those Connect assignments. And they really, I can tell you, I've been teaching here for years. I've been doing this for years. I have data to support what I'm saying right now. Do these assignments as soon as you have studied the material, as soon as possible, right? Take it as if it's a quiz, right? To see what you actually truly know. Because a lot of times students are studying and they're not getting it. This is going to tell you before the test, crap, I don't understand this, right? I also have them set in Canvas, in Connect for you guys. Oh, these C words are going to drive me crazy, right? So that I set deadlines for you, right, as a guide. This is as a guide, right? They're not hard deadlines. I can go in and change them to hard deadlines. Please don't make me do this, right? Please do them as soon as you can, and then if you want, maybe do them again before the test. But what I mean by they're not hard deadlines is they're all still open. Even though there was a deadline, y'all, you can still do them again and get the highest possible score. So when you guys come begging me at the end of the semester for a point or 2 or 10 points, I'm going to say no, because you should have done your Connect, right? And I'm going to give you guys until the last possible day to max out your Connect points. And today I'm going to give you guys a ton of bonus opportunities, like way more than I probably should. Okay? So other than that, just do your work. Don't wait till the last minute on your Connect assignments, right? I have students who failed their online test, right? I look at their Connect assignments, they failed them. I'm like, how could you fail Connect assignments and think you're going to pass a test? I don't know about you, it does not make sense to me, guys. It does not make sense, right? If you are not getting this, come see me, call me, text me, right? I love talking about this stuff, right? I think this stuff is super cool. You may think I'm crazy for that, but hey, that's me. Okay?
When are we taking the test?
Hmm?
When are we taking the test?
Next week, Tuesday.
Are we taking that to
John, check Canvas. Have you done your Connect assignments? You're going to be in a doghouse, boyfriend.
I did all of them. Even the bonuses.
Oh, good.
I got 100.
Then I'll forgive you this one transgression of not checking Canvas.
It's ready, y'all.
That's good. You'll ace it next week on Tuesday in the Hibernia Center when we actually take it. All right. So everyone understand about midterm grading, what will be imputed, what you need to do, get your ducks in the row, right? Okay. Listen to my recording, John, since you can't seem to make it to class on time. So I'm not repeating myself. Leave earlier. Okay, so one of the bonus opportunities is today. And it's called Delgado Day. And so you guys will notice, and I put it a module for bonus because, like I said, there's a bunch of bonus that I'm going to post for you guys that you can do. So the first one is today for Delgado Day. It's from 9 to 1 today. There are several high school students coming to tour Delgado. The biology department is the feature, and specifically the biotech program. So I had a spy. She's not come back yet. They have tables apparently set up in the gym. I haven't had a chance to check that out because, as you guys know, I teach a class in here at 8 o'clock before your class. So I'm stuck here until I'm done with you guys. So I had one to go check out and see what's going on at the gym. So we need students at our table to talk to prospective high school students that are coming in today about the biology program. And so If that table isn't manned after this class, I ask that you go there and volunteer whatever time you have, half an hour, an hour. If you do a whole hour and you submit here and tell me you did an hour, if you take pictures even, right, you can submit them to me through this link, this submit assignment link, and I'll give you 10 points for an hour and 5 points for a half hour. And it's available from 11 to 1 today. If the table's manned in the gym, I ask that you head over to the microbiology lab. And it's okay if you've never taken microbiology, right? I just need people in there, and again, to talk to prospective students about the biology program in general. And then I have a few activities set up in there where they look under the microscope and they look at stuff. And so those you guys, too, that might not be taking lab, it's a cool opportunity to go into lab and see what it's all about, right? And so help out there if the gym is covered. I, of course, will be heading straight to the lab after this class, and we'll be there until 1 o'clock today. So any questions on that? Anybody think they'll be able to help out today? I know it's short notice. Sucks. Okay. All right. Anyways, that's not the only bonus opportunity coming up. So I'll post another assignment like this with this information too. But I think this one you guys definitely would be interested in. I know I'm going to be there. So we have Dr. Rittard, who's actually Dr. Rittard's here's dad. He's the state epidemiologist, and he's coming to speak to us next Monday at 2:30. Second floor of the Student Life building and the Lake Maupaw room. If you go to this talk, take notes, and again, I'll have an assignment link. If you write me a little paragraph about what you learned, whether you liked it or you didn't like it, this talk, then I'll give you up to 10 bonus points for attending and writing about it. So as you can see here, is going to be talking about emerging viral diseases like Zika and dengue virus. So I'm really looking forward to this particular talk. So if you can attend and write a little something about it, you can get bonus points for it. The other one that's coming up, I got bombarded last night with everything. I was like, oh my God. Is one, if you guys are in anatomy and physiology, maybe interested in. This is another relative of a colleague here at Delgado. This is Dr. Rosenwig's brother, Seth Rosenwig. He's coming to talk Thursday, April 21st at 3 p.m. I'm going to try and make it to this one. It's kind of tough. This is in, I noticed, where does she have this one? Oh, Building 7. Y'all, that's our brand new library building. Apparently it's starting to open up, at least hopefully soon. But somewhere in that building apparently is room 183. I've only been in there once, briefly. And he's going to talk about musculoskeletal health. So I'm definitely, interested in the immunological component, if anything, that he may talk about in this talk. So if you go to this talk, one of the things I really want you guys to pay attention to and make note of is any reference to immunology, right, and the immune system and how it affects health. Did I say? Oh, look at, she's got it. She's got Thursday here and Wednesday here. I will let her know. She needs to fix it. So, yeah. I see that. I will send her a note right after class about that. So, but that one's a little bit further away. Thank you for your attention to detail. I didn't catch that because, like I said, I got bombarded with all of this stuff yesterday afternoon, last night, in the midst of setting up for today. So, and then one last one is going to be April 8th, which I know for a fact is a Friday. It's an all-day event. It's the event that I run. It's called the Science Expo, and we will be, again, set up in the gym with tables in the gym, and I need students to volunteer and man the microbiology tables. So similar to kind of what I have set up in the lab today, interactive, looking under microscopes, looking at microbes, and, talking to students as they come by the table. And so that's an all-day event from 9 to 3, And again, depending on how long you sign up will determine how many bonus points. But I'm also going to have to put a bonus point cap on, because there's only so many bonus points I'm allowed to let you guys have. So I have to mathematically figure out what that maximum is for this class, and I'll let you guys know. But there's plenty of opportunities that you should be able to max out your bonus, whatever that number may be. I'm thinking it's probably going to be 40 or 30 for this class. I'm not sure. But I will let you guys know this week, so you can plan accordingly. Make sense? All right, so let's rock out what we got left of this stuff. And so we will, I don't see for any reason why we wouldn't finish what we have left for this module today. So guess what I'm going to do on Thursday? I'm going to start a new module, right? So, you know, today, sometime, or tonight, I will post all the stuff for the next module. And we will start that on Thursday, but of course it's not on Tuesday's test, right? Okay. Like, where is my PowerPoint? So, last time, I'm pretty sure we went through all the temperature stuff, right? And remember, the important thing here with temperature is, you know, knowing the range, the order, right? That psychophiles is the coldest, then psychotrophs, mesophiles is right there in the middle, is us, thermophiles, and then hyperthermophiles. And what type of environments are we talking about in relationship to these categories, right? We're not memorizing any of the number ranges, right? Yeah. Okay. So now let's move on to well, let's wrap up. So we've been talking about growth, but we know, right, that we can use temperature to control growth, right? We use cool temperatures to slow growth and maybe even stop growth of microorganisms. But again, it really depends on where that microorganism falls in the category. Most of the ones we're concerned with are mesophiles, right? Ones that would grow inside of us. So refrigerating them is going to slow them down. Freezing them is going to stop them. It's not going to kill them. How do we kill them? Heat. We cook, right? We heat. And that's why for certain foods we have certain temperature ranges. Again, because the most common pathogens, microbes that would be contaminating that food are killed at that temperature. That's why the different temperatures for the different meats. Wow. So that's how changes in temperature can control the growth of microbes, right? We can cool them down, slow them down, or stop them. We can heat them up and actually kill them, because then we're changing the structure of proteins and melting membranes and shutting the system down. Why do endospores, though, pose a serious health risk when using temperature as our means of control? Heat does not destroy them. Yeah, heat does not destroy them. Not all forms of heat, we should say. Boiling will not destroy them. So when they tell you to boil your water, are you destroying endospores? No. Are there probably endospores in your water that are going to make you sick? No. 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 That's why it's sufficient enough to say boil it. Right? We're not sterilizing, we're disinfecting in that case. Right? For that source, that's sufficient. But if you're going to eat dirt, right? Good old mud pies like I did when I was a kid. Cooking those isn't going to help you, because there are endospores present there that can make you sick. Anyone know what a common soil contaminant? Tetanus. 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 Tetanus is a spore former, and it's commonly found in the soil. And our traditional forms of heat, like boiling or standard cooking, are not going to destroy those endospores. Anyone know what would destroy an endospore? Burning it. Completely incinerating it. Well, I don't know about you guys, but there's really nothing left but ash and minerals when you incinerate something, right? This is why we do that to biological waste, right? Why we burn carcasses. We refer to that as cremation, right? Medical waste is burned because all you're left with is carbon, ash, and minerals. All the water has been removed. That's a really intense heat. But you're also really not left with anything you want or could do anything with, right? That we could anyways. It's disintegrated. That's what we do in the microbiology lab. When we put our loops right directly into heat, you're incinerating, right? That's high heat right into the flame itself. What's another, you could say, instrument that we employ for microbiology or in the medical field to sterilize things? Autoclave. And we do sterilize because what do we destroy in an autoclave? Endospores, all endospores actually. All endospores, if your autoclave is working properly, will destroy endospores. And it's high pressure steam, right? So there's that moist element which helps heat penetrate, and it's under pressure. And that's enough to penetrate that really tough spore coat. So there's another endospore that we worry about getting into our food. Anyone know? It can cause food poisoning. Nope. It starts with a B. People purposely inject the toxin it produces. Botox, right? Is the trademark name, I guess, that the toxin produced by botulism, right? So that's a spore former. It's also an anaerobe, which means it grows in an environment without oxygen. So when we can foods, if that endospore gets in, it will germinate in that anaerobic environment we create when we can foods or jar foods. So then it can grow. It produces the toxin which is released into your food. And then if you don't cook that food, you ingest that toxin, right? And it could make you very sick, even kill you. So in the canning industry, they're really concerned about making sure that that's not present, right? And to preserve the stuff as well as possible to prevent that from happening. So you always hear the wise tale, and this one's not a wise tale. Beware the swollen can. If it's swollen, it means something grew inside of it. Leave it alone. I have to say I've actually seen this once, cleaning out Grandma's shed after she died. She had some cans that had been in there for a long time. Right? Dented cans are fine as long as they're not punctured, right? Just means somebody dropped it, right? It happens, right? If you drop a can and you dent it, it's fine as long as it's not punctured, because if it's punctured, that means something could have gotten in, right? And you don't want to risk that. If you're going to cook the food, then, again, you're less likely for something bad to happen to you because the toxin is heat liable, which means it can be destroyed by heat. So they always say, home canned foods, be careful because, it's not a strict regulation like we do in the commercial canning industry. But again, a lot of the food outbreaks we have happen because of mass production of food distributed, right? And when a place gets contaminated, like what happened with good old Bluebell and Listeria. Make sense? Okay. So yeah, endospores, because, they are quite resistant to most of the heating ways we use at home, they could cause a serious problem for us. So the next thing we're going to look at is oxygen concentrations, requirements, and tolerances. So you need to be able to identify the categories that use oxygen for their metabolism out of the 5 categories. You need to be able to name the enzymes that can protect organisms from the toxic forms of oxygen and identify what they do. And be able to classify organisms based on their growth patterns in the FTM media, which is fluorothioglycolate media, which those of you guys that are taking lab, pretty soon you're going to use that. And so you'll actually get to see firsthand the different growth patterns. And they set up different patterns because of the different oxygen zones that's created by using this media. So this is examples of all the 5 different categories, their growth patterns in this special media. This special media removes oxygen from the bottom of the tube, right? When they're fresh, the bottom of the tubes are said to be anoxic. They do not contain oxygen. So if you see growth, and the dots represent bacterial growth, if you see growth in that zone, it means that the organism is growing what we say anaerobically, right? So notice that you have growth here, which means it's growing without oxygen, which means anaerobic. If you see growth in the oxygen zone, usually means that it's using oxygen. And so for this very first tube, it's only growing in the oxygen zone, right? That means that this organism requires, it cannot live without, has to use oxygen for its metabolism. So they're said to be obligate or strict. These 2 terms are typically used interchangeably. Aerobe, meaning requiring oxygen. Because this organism lives in an oxygen environment and is utilizing it, it's exposed to the toxic forms of oxygen. Believe it or not, oxygen can be toxic. Because of that, organisms that live in the presence of oxygen, and especially if you utilize oxygen, you have to have at least one of these protective enzymes. And that's what they're showing you here is enzyme content. So SOD, and I'll flip to my next slide because it has it written out, is superoxide demutase. So that enzyme breaks down the superoxide radicals that form when you live in the presence of oxygen and form more when you're using oxygen as a form of metabolism. It will break that down into safe oxygen and hydrogen peroxide, which is also another damaging form of oxygen, but is not as damaging as the superoxide radicals. But then, because hydrogen peroxide can be damaging, a lot of organisms that live in the presence of oxygen, and especially if they utilize oxygen, so they produce more damaging forms of oxygen, have an enzyme called catalase. This enzyme breaks down hydrogen peroxide into water and gaseous oxygen. So if you've ever poured hydrogen peroxide on a wound, you notice what happens. It bubbles. And that's because of the oxygen gas being released by the enzyme catalase breaking down the hydrogen peroxide. You are catalase positive. You are an aerobe, are you not? If we don't have oxygen, what happens to us? We will die, right? So we have this enzyme. We have catalase. Every time you pour hydrogen peroxide on you, it should bubble. If it doesn't, it means that your hydrogen peroxide is old. Because you're always going to be catalase positive. You always have catalase. Your hydrogen peroxide is kept in a dark bottle because light can also cause the reaction of breaking down the hydrogen peroxide into water and gaseous oxygen. So if it doesn't bubble, you mostly just poured water on yourself. And that's why it's not bubbling. It's mostly water, not hydrogen peroxide. So the old wise tale that if it doesn't bubble, it means it's not infected, 100% wrong. It should always bubble. If it doesn't, it means your hydrogen peroxide is old. Throw it out and buy some more. But actually, physicians suggest now that you do not use hydrogen peroxide for wound care anymore. Instead, good old soap and water and a little bit of triple antibiotic ointment. The reasoning behind that is that that bubbling action, although it's in that amount of hydrogen peroxide, would overwhelm bacterial cells. It's like throwing Katrina at them. It's more than they can handle. But it's also quite damaging to your own cells. So it's really not worth the risk of the damage that it creates to your own cells and the fact that it would definitely annihilate the bad guys. That's as it relates to your skin. But cleaning anything you want in your house, including your laundry, fantastic. So don't throw it out. It's cheap. I mean, you can get it for, what, 80 cents at Walgreens. Right? It is a good disinfectant, right? And actually can be used as a sterilant in vaporized form. So it can actually sterilize. And your body actually produces hydrogen peroxide to turn into toxic forms of oxygen to kill microbes, but in a controlled environment inside your white blood cells. Make sense? So oxygen is toxic, right? And becomes even more toxic when you're utilizing it because you'll sometimes produce these toxic forms. So it makes sense when we look back at this diagram that organisms that are living in an oxygen environment, and especially in this case, utilizing oxygen, that they have both of these enzymes, hence the plus. Then when we swing over here to the other end of the spectrum, notice that strict anaerobes don't have any of the protective enzymes against oxygen. That's why they cannot live in the oxygen environment. It would kill them. And hence why, you know, for some wound care and such as that, have you guys heard of using hyperbaric oxygen? So this is oxygen under pressure. Right? So my father-in-law cut his hand on the table saw several Thanksgivings ago. And one of the things that they did after his surgery was that he went and put his arm in a hyperbaric oxygen chamber, and it pushes the oxygen into the tissues. That's going to help your cells themselves by having more access to oxygen heal faster, but it also helps prevent anaerobic infection. So if you don't have oxygenation within your skin because within the tissue because it's repairing the blood vessels and everything that were damaged due to that injury, then this is going to help keep those anaerobes out and keep them from being able to establish residency because we're pushing oxygen in, right? And it would kill them. So it's twofold. It's going to help the tissues themselves heal, and it's going to prevent infection. So it's pretty cool. And it's all based on this principle that oxygen, especially for anaerobes, is toxic, as well as our cells need oxygen to grow. So if these guys are metabolizing without oxygen, that means that clearly they're not using it for their metabolism either, right? It means they're using something else as their electron acceptor. And that's why oxygen is important for those of us that are aerobes, right? It accepts those electrons at the end of the electron transport chain. Do you guys remember that from biology class way back when? Right? And it forms metabolic water. I know, seems like ancient history, right? But that's why, you know, we need oxygen, right? That's where our electrons go at the end of the electron transport chain. Those electrons that we took from glucose, right? And broke down in glycolysis in the Krebs cycle. It's not all that different for microorganisms, right? They do the same stuff we do for some of them. Now, when you get to these guys, aerotolerant. So as the name implies, how do they feel about oxygen? They're like, yeah, I can tolerate it. Why can they tolerate it? Because they have the most important protective enzyme, superoxide demutase, to protect them. But do you think that they're utilizing oxygen for their metabolism? No. One, they don't have catalase. Two, they're an anaerobe. their growth pattern between the oxygen and non-oxygen zone is the same. Notice growth is uniform all throughout this tube. If they were using oxygen, their growth would be greater in the oxygen zone. So when you look at our facultative anaerobes, even though they can grow anaerobically, right, you see that? They can also grow aerobically, and notice in the oxygen zone, they grow more. You actually get the most energy from aerobic respiration than you do from any of the other forms of anaerobic respiration. So it's like if I told you I'm going to pay you $32 an hour or two, which one would you pick? $32, right? They get around 32 ATPs per glucose molecule when you have oxygen as your final electron acceptor. Most of these guys are fermenting when they're in an anaerobic condition. They're only getting about 2 ATP for each glucose they're digesting. So their growth is much slower, right? Their energy yield isn't as good. But hey, they're still alive, right? Sometimes you make these trade-offs, right? I'm still alive, still kicking, right? So for facultative anaerobes, right, and this is great. Facultative means the ability to change. When oxygen's present, man, they're going like gangbusters. Aerobic respiration, on board, lots of energy, lots of growth. When oxygen isn't available, they switch to fermentation. Not as much energy, but hey, they're still growing. Good old E. coli that lives in our gut, right? Our gut, mostly an anaerobic environment. Sometimes a little bit aerobic. Most of the time they're fermented. But hey, they're alive, right? This ability to change is really beneficial. Aerotolerant. Again, they're not using oxygen. They're anaerobic respiration or fermentation. They're tolerating oxygen. They'll grow in the presence of it, but it doesn't kill it. Unlike our strict anaerobes, they're just doing anaerobic respiration or fermentation. They cannot grow in the presence of oxygen. It will kill them. They have no protection. Did you still have a question, Dan?
Yeah, so the anaerobes are only limited to glycolysis?
No, anaerobes, it depends on the organism. If they're doing fermentation, they use glycolysis and then they modify the molecule to recycle their electron carriers. But some organisms can do anaerobic respiration. And that's where, and you don't, I want to talk to you, so don't run away. Yeah. They have an electron transport chain, but instead of oxygen being the final electron acceptor, it's some other molecule. And it doesn't yield as much energy, though, because it's not oxygen. Does that make sense? Obviously not the level you need to know for this class. Sometimes that level of detail helps us. So how's it looking over there?
Busy.
Busy?
Yeah.
Busy. Do we have people at our table?
It looks good.
It looks good.
Yeah.
It looks good. Thank you.
Yeah.
Appreciate it.
A lot of people in the gym too.
Cool. Did you check my lab too? I was wondering why you were gone so long.
Yeah, I went to the lab because you're set up in the lab. Not
Right.
in the gym.
Yeah, but you checked the gym for me.
Yes, I went to the gym.
Okay. Okay, and I got coverage both places.
Yeah.
Awesome. Thank you. That's pretty impressive for like yesterday afternoon. I was reminded that we had this event today. So I'm happy. I'm definitely happy. So yeah, so you're going to see a lot of high school students on campus today, like hundreds coming today between 9 and 1. Just, be aware of that. Should be interesting. They come every year, right? I don't know if you guys have noticed this particular day. Every year it happens. For the last one, microaerophiles. So, right, we know a lot of information so far by that growth pattern and the name itself, right? So they're growing where? In the oxygen zone, right? But notice their growth isn't huge and it isn't all the way at the top of the tube. There's a reason for that. Micro means what? Small. They require small amounts of oxygen. And in fact, normal atmospheric levels of oxygen kills them. Why? Yeah, their catalase is limited. Right? Their protection is limited. So therefore that limits how much oxygen they can be exposed to before it kills them. But they only need a little bit to grow. They only need a little bit of oxygen to grow. But they're definitely dependent on it, right? Because do you see them growing without oxygen? No. So they're like us, the aerobes over here, except for them, small amounts of oxygen. So there is a particular microbe, Helicobacter pylori, can cause gastric ulcers. And it's a microaerophile. And if you think about the environment it lives in, your stomach, what's the oxygen content there? Probably low. Not zero though, right? But low, and sufficient enough that they're going to survive. Right? So growing in the lab, what do you guys think? Yeah, not so good keeping microaerophiles happy, right? Because, you know, we got to limit the amount of oxygen. So we need special chambers to keep them happy. What about strict anaerobes? If we made the lab anaerobic, what would happen to us? We could not survive in the lab. We'd die, right? So again, we've got to use special chambers to eliminate oxygen to grow anaerobes. So as you can imagine, our microbiology lab here at Delgado is not well equipped for those type of environments. We don't mess with anaerobes or microaerophiles. It's too hard to keep them happy, or alive for that matter. All the rest, no problem, especially obligate aerobes, right? We've got plenty of oxygen. We're not dropping dead in the lab, so they're not going to either. Facultative anaerobes, they're really easy to make happy, right? Because they're really happy with oxygen. If you take away the oxygen, they're like, oh, okay, no problem. I'll just, you know, anaerobic respiration, or I'll ferment. And then again, aerotolerance, as the name implies, they can tolerate the oxygen in our lab. They just don't use it, right? They're like, okay, no problem. I don't want to use it, but it's okay that it's there. Does that make sense? Right? So really, you know, when you guys get your unknowns next week or this week, depending on which lab you're in, you know, these are your 3 choices. It's either an obligate aerobe, a facultative anaerobe, or aerotolerant. Right? We're not messing with any strict anaerobes or microaerophiles. So we've already talked about the enzymes. So as I've kind of alluded to, what special cultivation methods do we need for some of these guys? Do we need special means? Yeah, we definitely do for those anaerobes and those microaerophiles. How do we use this knowledge about oxygen need or oxygen toxicity to affect microbes as it relates to especially our food? What's really popular nowadays as far as preserving our foods?
Freezing?
Freezing? But how would that affect oxygen? Or would it? No. But before you put it in the freezer, a lot of times you do what to the container? You seal it and suck out what?
The air.
The air, which contains oxygen, right? Vacuum sealing is very, very popular now. I mean, you know, Ziploc has got a little pump you can buy now for their little baggies, right? Or you can buy specialized machines that suck out the oxygen.
I got one of those.
Yeah, they're pretty cool. So that's great, right? Is it though? Right? Because we just created what type of environment by sucking out the oxygen? Anaerobic. Can some organisms grow under that environment?
Yes.
Yeah. Some anaerobes that can cause serious problems for us, like botulism. What's the chances of that it's in your food? Depends on where the food came from, right? And that's why it can be really helpful for some foods and not so helpful for others. And so that's the kind of crappy thing too, is like when you think about food preservation, there's no one perfect method that you could do to all your foods. It's really a situational thing, right? What's best for what I'm dealing with and what I have available. But it certainly helps, right? Especially when we're talking about aerobes, because if you suck the oxygen out, are they going to grow? No way. You just killed them. If they were there, they're dead now. So sometimes we even combine things, right? So we'll suck the oxygen out and then we'll freeze it. Freeze drying is very common. Right? Coffee is freeze dried. We keep our coffee in the fridge. Most places do. Keep your coffee grinds in the fridge. Long-term storage in the freezer. Make sense? Okay. So this specialized apparatus is for growing anaerobes. So they suck the oxygen out. So it has its own incubator, workspace. As you can see, the scientist is putting her hands through the gloves. This is an entry chamber, so they'll put stuff in, they'll suck the oxygen out. Then there's another door right here the scientist would open and bring the stuff in to the already eliminated chamber where there's no oxygen. So what type of equipment is very popular for preserving our foods that does this? We just talked about it, right? That's those vacuum sealing chambers, right, where we're sucking out oxygen. So what types of organisms are prevented from growing in this environment? Aerobes, right? Aerobes aren't going to grow. Are facultative anaerobes going to grow? Yeah, because they can grow anaerobically. They just prefer aerobically. Are your aerotolerant anaerobes going to grow? Yeah, because again, they're anaerobic. They just can tolerate oxygen. In this case, you just made them happy. They don't have to tolerate it, right? Your strict anaerobes, this is what they require, right? You've got to have this type of setup to be able to really scientifically work with them. Are your microaerophiles going to survive? No, because this is elimination of all oxygen in this apparatus. So what happens when this thing springs a leak, though? If you're working with strict anaerobes, they die. And so I had a friend of mine at Southeastern when we were in grad school. She was working in the microbiology lab. I was in the immunology lab. She switched to my lab. This thing sprung a leak twice on her and ruined all her experiments twice. She got fed up and switched to immunology. You know, if the equipment doesn't work, you can't do your experiments. So again, this is not the easiest type of environment for the study of these types of organisms. A little bit more labor-intensive and not as sustainable for long periods of times are the anaerobic jars. And we have some of these, you'll notice, in the microbiology lab, but we don't use them anymore. Believe it or not, one of these jars costs about $800 a piece. And several of ours, the seal is broken, so we can't seal it tight. And the way this works is you put a gas pack in it, and once you seal up the container, a reaction starts. And the gas pack releases hydrogen gas and carbon dioxide gas. The hydrogen combines with the oxygen gas in the chamber and converts it into water. So it removes the oxygen by turning it into water. And then, of course, with our human eye, we cannot tell if, other than you can see sometimes the condensation of the water, you can't tell if all the oxygen has been eliminated. So we use an indicator. Methylene blue, that particular dye, under aerobic conditions is blue, but under anaerobic conditions, it's colorless. So you can tell by having a methylene blue strip or tablet in there, and when it turns white or clear, you know that you've created an anaerobic environment in that jar. But you could also determine that if you put some known organisms in. So can an aerotolerant microbe survive in this chamber? Yeah, and even if it springs a leak, it's still going to be fine, right? So that wouldn't be a good indicator organism. But can an aerobe survive in this chamber? No, if we put an aerobe in, we truly create an anaerobic environment. What's going to happen to that one? We're going to kill it. We're going to kill it. Who's going to survive in this chamber? Why would we even set this up? We want our strict anaerobes to grow. But who else will grow? The facultative anaerobes. The facultative anaerobes will also grow. Microaerophiles, no. Because again, you're going to remove all oxygen. They got to have some. So the last thing that we're going to look at is pressure, right? And so normal atmospheric pressure, most of us, we do fine with. Where on Earth, what environment creates a lot of pressure and organisms have to deal with it? Ocean, right? Water, aqueous environments. The further down you go in the water column, all the weight of the water on top of you is pushing on you. This is why submarines can only go so deep without the water crushing them. So, and obviously if you're crushed, you're dead, right? So, you know, obviously organisms in aquatic environments have to be barotolerant. They have to be able to tolerate increased levels of pressure. Or some of them have adapted so much to aquatic type environments that they became barophilic, where they require that high level of pressure in order to survive. You take them out of that pressure zone, they just can't maintain their stability. We're starting to use pressure more and more. They're actually pressurizing foods and such to try and kill microorganisms to preserve food. And that isn't our last one because we still have radiation. So there's 3 different types of radiation. We've talked about one of them already. It's in the light that we're exposed to from the sun all the time.
UVA?
UVA and UVB. Right? And remember, what does that do to your DNA? Causes the thymine dimers, which distorts our DNA, right? Which makes it unreadable by our enzymes. So we have to have enzymes again to repair that damage. But if you overexpose an organism to UV light, you damage their DNA, you could potentially do what?
Kill it.
You could kill it, right? Or you could definitely mutate it, right? Which sometimes, as we've learned, not a good thing. Anybody know of another form of radiation? X-rays. X-rays are a form of ionizing radiation. They're literally halting, throwing electrons at you. This can break your DNA backbone, and it's really bad when it breaks it all the way through, right? Breaks both strands. You know, if you just nick one strand, you know, enzymes can repair that damage. But when you start chopping up DNA into pieces, it's really bad. And then there's gamma radiation, which again is ionizing, throwing electrons at you. Can be really damaging form of radiation. So why can we survive exposure to radiation? What do we say? We have protection. What protects us? The enzymes, right? The enzymes that repair the damage that radiation causes. But again, if you get exposed too much, more than your body can repair, that's when you run into problems. This is why no one's going to agree to be X-rayed every day, right? No one's going to purposely expose themselves to radiation, and why you should really consider limiting your exposure to sunlight because of the UV radiation to your skin. Right? So can we survive exposure to radiation? Absolutely, right? We do have some protection because we can't avoid it. We live on Earth. We're exposed to UV radiation. Ionizing radiation is the most damaging, creates the most mutations and the most probable causes of death. because of its disruption to the structure of molecules and especially to DNA. We can repair a certain amount of damage, right? It's when we get above the level of protection. For UV, again, those mutations, if extensive enough, can lead to death. What is actually happening at the cellular level to the DNA is a distortion caused by the thymine dimers that form. And that's a covalent bond, that's a strong bond. The problem with it is the distortion to the DNA backbone and the inaccessibility to the enzymes that read DNA, and therefore shutting down, right, our command center until this problem can be fixed. So where in this strand would we have a problem? Right at the end where you have thymines next to each other. You got to have two thymines, at least two next to each other, to get them to dimerize. Visible light, especially organisms that are purposely absorbing light, this can unfortunately cause another damaging form of oxygen known as singlet oxygen, which is a very powerful oxidizing agent. It likes to steal electrons. So carotenoid pigments, so photosynthetic organisms, plants, algae, photosynthetic bacteria, some of their pigments, part of their job, other than absorbing light energy to excite their electrons to generate the energy necessary to build their molecules, some of them also have to protect them against the formation of this singlet oxygen. So part of their job is to neutralize singlet oxygen from the absorption of light to excite electrons. You know, we've got to be controlled in how we're dealing with this energy, right? So, of course, it's photosynthetic organisms that have to worry about this. So the very last objective, we've been talking a lot about growth in laboratory settings and such, right? This is artificial growth situations, right? This is not how growth happens in nature or for most biological systems. They don't live all by themselves. A lot of microorganisms work in conjunction with one another. And this is how biofilm formation happens, and a really interesting phenomenon of quorum sensing. So there's a animation for biofilm that I'm going to show you guys in a moment. We'll talk about quorum sensing before that. So most of the environments that our organisms are living in, natural environments, are very low nutrient environments, what we refer to as oligotrophic. And you know, overlapping, changing environments. And this is definitely very evident as it relates to biofilms. So because of that, right, because they have less nutrients, they tend to be more competitive because they got to get the food. They can even increase their surface area under certain circumstances, oh my God, to absorb more nutrients. They sequester nutrients. Remember how we talked about inclusion bodies, right? You know, they're going to store it up. If something is available, they're going to store it up, but they're going to store it up in a packaged form so it doesn't affect their osmoregulation, right? That whole water problem. Biofilms are ubiquitous in nature. What does that mean? They're found everywhere. They're complex. They're slime-encased communities that attach to surfaces. And so this creates a really serious problem for medical devices, such as implants, and can often lead to serious illness. And they can form on any conditional surface, basically any surface you can imagine they can form on. You have a biofilm. All of us are sitting in this classroom right now with a biofilm on your teeth, right? So microorganisms, bacteria stick to your teeth, right? They attach, they form this matrix, right? We know this as plaque. You want to remove this because those microorganisms produce acids that deteriorate your teeth and break down your teeth. The more sugar you eat, the more acid they produce. So if you're a sugarholic like myself, you just eat your sugar and then you go brush your teeth and floss, right? Because brushing alone cannot get the food in between your teeth, okay? And this is why we brush, why just mouthwash isn't really going to cut it, right? Because again, they're attached to your teeth. So you physically have to brush to remove them. And why even then you don't get it all, right? You got to go to the dentist every 6 months and they really scrape away at your teeth. Because you really want to remove that biofilm because it's damaging to your teeth. Now people who have things like hip and knee replacements nowadays are running into this problem too of microorganisms attaching to those devices, right? Unfortunately, we have not come up with a substance yet that the bacteria won't attach to. If you can figure that out, you'll be a gazillionaire, right? Because nowadays, because guess what, y'all? Can we go in and scrub it off like you scrub the biofilm off your sink?
Oh, that'd be pretty dangerous.
You would just be releasing them into the body, too. How could you do that cleanly, right? Where you're just scrubbing it off the hip replacement and not getting into it's just not possible. So when a biofilm forms on one of those medical devices, guess what they've got to do, y'all? Take it out and put a new one in. If you know anyone who's been through that surgery the first time, can you imagine having to go through it again? But we can't clear up that infection because we can't get it out. Antibiotics can't penetrate. So I'm just about out of time, right? So make sure, I'm going to have you guys watch the biofilm on your own, but give me 2 minutes because this one's really cool. So quorum sensing. So you think microorganisms live in their world all by themselves and they don't communicate with anyone else? Not so, right? A quorum is an amount of people you need usually in a legislative or a voting body, right, in order for a vote to pass. In this case, they're using quorum as you need to have enough organisms to accomplish a particular goal. And this is my favorite example. These guys are so cute. These cute little squid. They have what's called an organ gland. And so this is a gland where microorganisms are growing, but they have to maintain a certain density because these organisms bioluminesce. They produce their own light, right? But you have to have enough of them all together that the light is produced. And therefore, again, it's beneficial to the squid having this light. It attracts food for them. So they've begun this symbiotic relationship with the squid, these microorganisms, but these microorganisms also have to maintain a certain population. Well, how do they make sure they have enough of them? They've got to communicate, right? They actually release chemicals that others can sense, and they get an idea about how many of them are present. So probably my best example of this is perfume, right? When somebody puts on perfume, especially when they've just put it on, we can really sense that that's the case, right? Because we can smell. Well, they have receptors for chemicals, and they can sense how much is present and figure out how many of them are present. And they don't use this just for like this situation. You know, they use it in other situations too. Are there too many of us? Should we stop growing? Right? So they actually communicate more than we ever realized, right? So this is a newer area of research of this communication among microorganisms within communities. Pretty cool research. So make sure you check out that animation. It's pretty cool. I think it does a good job of describing biofilm. It should be on our list for this module. Animations and videos. Right there at the bottom, it's a link, biofilm. So check it out. It's worth a minute or two. All right, if you guys can help out today, I greatly appreciate it. All right, but look for the other bonus opportunities that I'm going to be adding over the next couple of days that are available over the next several weeks.
Do you want me to put on the laptop?